Good morning students, this is the class for 10th standard science subject. In chemistry our second lesson is atoms and molecules. Okay, in previous classes we have seen the definition of atom, then molecules, and also the atomic mass, as well as the main postulates of modern atomic theory. Okay, so to continue that lesson, now we are going to learn about the RAM. Okay, that means relative atomic mass. Okay, on that day we saw the atomic number and also the mass number. The mass number is otherwise denoted as atomic mass, okay, or otherwise called as atomic mass. Okay, so now we are going to learn about the relative atomic mass of an atom or an element. Okay, so it's shortly denoted as RAM. Okay, then an atom is very small. Okay, that we know. Okay, an atom is very negligible amount, that is very small. The mass of an atom cannot be determined directly. That means the mass of the atom can be calculated by direct method. Okay, so we have to introduce a indirect method. Okay, so the scientist established one element as a standard one. Okay, so the scientist enna pannanga appadina, he established, okay, so they established one element as a standard one. Okay, ஒரு element or ஒரு atom standard one வச்சிட்டு அதர் ரெஃபரன்ஸ் ஆட்டமா வச்சு அதுக்கப்புறம் என்ன பண்ணுவாங்க, மித்த அதர் ஆட்டமோட அந்த அட்டாமிக் மாஸ் எல்லாமே கால்குலேட் பண்ணுவாங்க. ஓகேவா, ஸோ த சயின்டிஸ்ட் எஸ்டாப்ளிஷ்ட் ஒன் எலமெண்ட் as a standard one, gave it an other arbitrary value of atomic mass, and using this value the mass of the atom or the value of measured the relative mass of other elements. Okay, so by using this method we can calculate the mass of an element. No, okay, so that method is known as the relative atomic mass. Okay, so by using this method we can calculate the mass of an element or mass of an atom. No, okay, so that method is known as the relative atomic mass or RAM. Okay, so at the beginning stage the mass of the hydrogen atom was chosen as standard one. Okay, beginning stage the mass of the hydrogen atom is chosen as the primary atom, and using this as a standard one comparing with the other elements. Okay, and using this compared with the other elements. Next, why they are choosing the hydrogen atom means because this is because of the existence of the isotopic character. Okay, the hydrogen which exhibits the isotopic character. Okay, that is hydrogen has a three subatomic particles. Okay, so these are the three isotopes of the hydrogen atom, that is H11, H12 and H13. Okay, deuterium, deuterium and tritium. Okay, so later the hydrogen atom was replaced by the oxygen atom. Okay, so at the beginning stage they are used as the hydrogen as a primary atom. Okay, so after a long time the hydrogen atom is replaced by the oxygen atom as a standard one. Okay, nowadays, okay, the stable isotope of carbon 12 atom. Okay, so the oxygen atom, okay, after that the oxygen atom, the stable isotope. Okay, stable means this is a fixed one. Okay, not changed or not varied. Okay, so the stable isotope of which one, carbon 12 atom with the atomic mass 12, okay, is used as the standard one. Okay, so this is the nowadays. Okay, this stage latest one. Okay, so which one, the stable isotope of carbon 12 atom with the atomic mass of 12, okay, is used as the standard one for measuring the RAM. Okay, that means the relative atomic mass of the other atom. Okay, so the definition of the RAM means it's the ratio between, okay, it's the ratio that is between the average mass of its isotopes to the 1/12th part of the mass of a carbon 12 atom, because nowadays we are using the carbon 12 as a standard atom. Okay, so that is it's the ratio between the mass of a carbon 12 atom and the average mass of its isotope. Okay, that's to a individual atom. Okay, so the RAM is denoted as, symbolically it was denoted as A suffix R. Okay, capital A suffix R. Okay, not small a. Okay, so the RAM is denoted as AR. So the next one is the RAM is otherwise called as standard atomic weight. Okay, the relative atomic mass is otherwise known as standard atomic weight. Okay, so the formula for RAM is equal to average mass of the isotopes of an individual elements, that is divided by the 1/12 of the mass of the carbon 12 atom. Okay, modern methods of determination of atomic mass by modern method means in nowadays, okay, latest time, the mass of the atom, okay, the mass of the atom or the atomic mass of the weight, okay, that was determined by using the mass spectrometry. Okay, mass spectrometry that uses the carbon 12 atom as a standard one. Okay, the mass spectrometry uses a carbon 12 atom as a standard one. Okay, for the most element the RAM is very closer to a whole number. Okay, most of the element the value of RAM is closer to the whole number, that is 10, 9, 8. Okay, not the decimal point like 9.88 something. Okay, and it's round of the values. Okay, whole number illama it's like 7.889. no, so இப்படி இருந்தாலும் என்ன பண்ணலாம், we have to round it off the value. For our convenient we have to round it off the value as 8. Okay, so next one is the RAM of some elements. Okay, that is relative atomic mass of some elements according with the carbon 12 scale. Okay, so these are calculated by using the carbon 12 scale. Okay, so the first one is what means element. Okay, then the second one symbol, then third one is the RAM value, that is AR. Okay, so for hydrogen the symbol is a H and the RAM value is 1. For carbon the symbol is a C and the value is 12. For nitrogen N the value is 14. For oxygen O the value is 16. For sodium the symbol is Na and the value is 23. For magnesium the symbol is Mg and the value is 24. Okay, and for sulfur the symbol is S and the RAM value is 32. Okay, this is according with the carbon 12 scale. Okay, so the RAM is only a ratio. Okay, that is already I told in the definition of the RAM. Okay, so it's the ratio between the two, so it does not have any unit. Okay, so there is no unit for RAM. Okay, so if the atomic mass of an element is expressed in gram, okay, so it has no unit means if the atomic mass of an element is expressed in gram, okay, grams means then it called as gram atomic mass. Okay, atomic mass is expressed in terms of grams unit means it's called as gram atomic mass. Okay, so the gram atomic mass of hydrogen is 1 gram and for oxygen is 16 gram and for carbon is 12 gram and nitrogen is 14 gram. Okay, so these are the gram atomic mass of some elements. Okay, so the next one is what means average atomic mass. Okay, so that is RAM is different from AAM. Okay, this means average atomic mass. Okay, so the definition of is this, it's the average atomic mass of an element is the weighted average weight. Okay, weighted average of the mass of its naturally occurring isotopes. Okay, naturally occurring isotopes means the subatomic particles of atom. Okay, so that is the naturally occurring isotopes. Okay, so the formula for AAM is mass of the first isotopes into percentage abundance of the first isotope. Okay, so this is the availability, this depends on the availability of the isotopes. Okay, plus mass of the second isotope into percentage abundance of second isotope. Okay, for example 9 into, okay, the mass of the first isotope is 9 into the percentage abundance is 50. Okay, so we have to calculate the percentage means it's divided by 100. Then the second one is 10 into 50 by 100. Okay, so we get cancelled, no, 0 0 will get cancelled, 1 5s are 5, 2 5s are 10. Okay, so 9 by 2 is 4.5. Here 0 0 will get cancelled, 10 10, so the 5, so 4.5 plus 5 is equal to 9.5. so this is expressed in the AMU. Okay, which means atomic mass unit. For example we have to consider the carbon 12 atom means, okay, so the average atomic mass of the hydrogen atom is 12.011 atomic mass unit. Okay, So next one is the atomic mass of some elements. Okay, so this is the atomic number and the name of the element, then symbol, then atomic mass, that is expressed in AMU, atomic mass unit. Okay, then atomic number for hydrogen is 1 and the symbol is a H, then atomic mass is 1.008. Then for helium He, atomic number is 2, the value is 4.003, and for lithium Li, the number atomic number is 3 and the value is 6.941. Okay, then for beryllium Be, atomic number 5, the value is 9.012. Then for boron, the symbol is B, atomic number is 5, the value is 10.8811. Okay, so we have to round it off the value, means for our convenient 1, this is 4 and this is 7, then this is 9 because 9.0. Okay, then this is 10.8 means it's 11. Okay, this is the atomic mass or mass number. Okay, then so next one is the what means a problem. In your book page number 94, below above the table 7.3 there is a one problem and below that there is a one problem. Okay, so we have to solve the two problems. Okay, so first one is calculation of average atomic mass solved example. Example 1 is oxygen is the most abundant element in both as well as the earth crust. Okay, and also the human body. It exists at a mixture of 3 stable isotopes is nature shown in the table 7.3. Okay, so you have to listen the table 7.3 carefully. The isotopes are 3 isotopes. One is oxygen 816 and another one is 817 and another one is 818. Okay, so the mass is expressed in atomic mass unit is 15.9949, then 16.9991, then 17.9992. Okay, so the percentage abundance is also given that. Okay, in that place. So we have to calculate the average atomic mass of the oxygen atom. Okay, so the average atomic mass of oxygen. Okay, the average atomic mass of oxygen is equal to, so this one is the first isotope, this one is the second isotope and this one is the third isotope. Okay, so this is given in the table. Okay, table 7.3, the second column. Okay, mass is expressed in atomic mass unit. Okay, so this is the referred to as table. Okay, so this one is the third column of the table, that is the percentage abundance, that is divided by 100. For example, 99.757 divided by 100 means we get the value of this. Okay, careful students, this one is the second column of the table 7.3 and this one is the third column of the table 7.3. The value given the table in the third column, that is divided by the 100. Okay, so that we can get the value like this for all three isotopes. Okay, so we have to simplify, means finally we get the value was 15.999 atomic mass unit, because the unit is AMU, that is atomic mass unit. Okay, for our convenient we have to round it off the value, means this 15.99 is taken as 16 and 0.99 is taken as 1 and this one is 16.9 is taken as 17. This one is assumed to be 0 because 0.00 something, and 17.9 is taken as 18 and this one is taken to be 0, means we have to get the value of 16 into 1 plus 17 into 0 plus 18 into 0, means these two, second term and third term will get cancelled. Okay, so we get only the first term alone, that is 16 into 1. Okay, so that is equal to 16 AMU. This is like this is. Okay, so 15.99 is taken as 16. Okay, so this is our convenient, we have to the rounded off the value, means. Okay, so this one is simplest way for our convenient, easy method. No, then second problem is boron naturally occurs as a mixture of boron 10, that is 5 protons plus 5 neutrons, and boron 11 is a 5 protons plus 16 neutrons isotope. The percentage abundance of boron 10 is 20 and for 11 is 80. Then the atomic mass of boron is calculated. Okay, so we have to calculate the atomic mass of boron. Okay, here the two boron, one is boron 10, another one is boron 11. Okay, so the boron 10 percentage value is 20. Okay, so we have to divide it by 100. Okay, so that is also divided by 100. 0 0 will get cancelled, 10 10, so the remaining part is 2 plus 0 0 will get cancelled, 4 2s are 8, 5 2s are 10, so 11 into 4 by 5. Okay, so 2 plus 11 into 4 by 5 is 4ன்றால இது பண்ண முடியாது. ஸோ டிஜிட் டாட் 0 வச்சு 0 சேர்த்துனா 8 5s are 40. ஓகே, ஸோ we get the value of 0.8. ஓகே, ஸோ the 0.8 is divided by 11 means we get the 8.8. okay, so 2 plus 8.8 that is equal to 10.8 atomic mass unit. okay, so this is the average atomic mass of boron element or boron atom. okay students, understand the problem? Thank you students.